Okay, welcome back, guys, for our second lesson on doing geometry on the coordinate plane, sometimes referred to as analytic geometry. And today our objective is going to be to find the midpoint or a missing end point of a given segment. And our other objective is going to be to take a given line segment and cut it proportionally. So in order to do those things, we need a little bit of vocabulary. We're going to talk about a midpoint and an end point. And then just a reminder that a proportion is a comparison of two ratios. All right, so in a proportion, one ratio is equivalent to another ratio. So that's how we'll work with that. So let's start with midpoint. The midpoint of a segment is the point that is the same distance from the two endpoints and between them, meaning that it's collinear, it lies on the same line. So the midpoint of segment PQ is M. It is the average of the two x values, halfway between the x values, and the average of the two y values, halfway between the y values. This gives us our formula right here, our midpoint formula. The x values added up and divide by 2 to find their average, and the y values add up and divide by 2 to find their average. So let's try an example. Our first example asks us to determine the coordinates of the midpoint of a segment with endpoints at -4, -8, and -6, -5. Okay, so we are looking for the midpoint of this segment, and we can approximate it. We can say that it is about here, but we're looking for the actual values of the x and y at that point, the coordinates of that point. Well, I know that the x value has to be halfway between the two x values that I have, so I'm looking for a number that's halfway between -6 and -4. Well, if I look on the number line or on the x-axis here, -6 is here, -4 is here, and we are looking for the number that is halfway between the two. So in this case, that number is -5. So we know that the x value of our coordinate is -5. We also need to find the number on the y value that is halfway between -5 and -8. So we are looking for the value halfway between these two values, which is -6.5. So we know that the y value is -6.5. We can also do this using our formula. So let's just get that formula back. So we are given x1 is -4 and x2 is -6. So -4 plus -6 divided by 2. That's -10 divided by 2 is -5. And then we have y1 is -8, y2 is -5. -8 plus -5 is -13 divided by 2, which is -6.5. So either the algebraic or the visual model will help you solve a problem to find the midpoint. In our next example, now we're given the midpoint. So let's just make a quick sketch of what's going on here. We're given that the midpoint of some segment RT is A. We know that R is 3, -4. And we know that A is -2, 5. So let's label those points so we can visualize what's going on here. Okay, 3, -4, and -2, 5. But here, we're not looking for the point halfway between A and R. We are told that A is the midpoint. So if the midpoint is here, that means that our other point must be way over here somewhere. So let's see if we can figure out exactly where. Well, I'm going to sketch this segment so that I have a nice visual of what's going on. And I know that the distance between the x value of A and the x value of R is 5 units. The y value distance between A and R is 9, from -4 to 5. But if that's halfway, then I can really just double those values to get all the way. So I can think of going back another 5 units and up another 9 units. So that's one option. I can go back 5 units from -2 to give me an x value of -7. And I can go up 9 units from 5 to give me a y value of 14. So visually, that's how we can find the coordinates of r. We could also think of this more algebraically. We know that the midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2, which means that when we take our endpoint r, x1, y1, and our midpoint of -2, 5, we know that 3 plus x2 divided by 2 has to give us the x coordinate of our midpoint, -2. And we know that for the y value, -4 plus our y2 divided by 2 has to give us our midpoint y value of 5. So we can also solve these algebraically. And we can now solve each of these equations for x2 and y2. So I'm going to multiply both sides by 2 to get rid of that 2 in the bottom. 3 plus x2 equals -4. Subtract 3 from both sides, and I get that x2 is -7. That's 5 units farther to the left than the midpoint was from the other endpoint, just like we suspected. And to find y2, we'll do the same thing. Multiply both sides by 2. I get -4 plus y2 equals 10. Add 4 to both sides to solve, and I get that y2 equals 14. So these tend to be the two ways that we see midpoint problems in context. We're now going to move on to cutting segments proportionally, not just in half. So there's lots of practice that you have today that's just on midpoints. If you want to get started on that, you can pause the video now and do that. Otherwise, you can keep coming along and learn how to divide segments in proportions other than 1:1. So let's take a look. A midpoint cuts a segment in a 1:1 ratio. In other words, the two pieces are equal. A trisector cuts something in a 1:1 ratio. All 3 pieces are of the same length. And what we're going to try to do today is cut things in other than 1:1 ratios. So our first task is going to be to cut this segment in a 3:2 ratio. So let's just remember for a second what it means to cut something in a 3:2 ratio. It means that one piece, the length of one piece, let's call that piece L1, and the length of the other piece, let's call it L2, need to be in a ratio, L1 to L2, equivalent or proportional to the ratio 3/2. That's what it means to be proportional. So if we want to cut this segment in a 3:2 ratio, we need to figure out what values of L1 and L2 will allow us to have, will be equivalent to 3/2. So let's see if we can figure this out. There's lots of ways to approach this. Here's one thought. I know that L1 and L2 have to add to this distance between the y values here, since it's vertical, to 10. So if I know that L1 and L2 have to add to 10 and they have to be in a 3:2 ratio, then I can just replace L1 with 3x and L2 with 2x, and I can figure out what I'm going to have to scale that ratio up by. So let's see, that gives me 5x is 10, which makes x equal to 2. So I know that L1 must be 3 times 2 is 6, and L2 must be 2 times 2 is 4. And look at that, we have a 3:2 ratio. So let's figure out where the point would be that cuts that in a 3:2 ratio. From 5, 1, 2, 3, 4, 5, 6 right here, and then we have 4 here, and our ratio is 6:4, which is equivalent to 3/2. So our final answer is going to be that the point that cuts this segment in a 3:2 ratio is 5, -1. So these problems do get a little bit more complicated when we have non-vertical and horizontal lines, but we can really always break them down into their vertical and horizontal components. So let's give one of those a try. In this problem, we want to find the coordinate of C so that segment AB is cut in a ratio of 1:2. So let's see. Again, we're going to need a vertical and horizontal component. So I'm going to use red for my horizontal component. That's going from -8 to 7. So I need to cut this in a ratio of 1:2. And we do need to make sure that since AC matches with the 1 and CB matches with the 2, C should be closer to A. So it should be somewhere in this area here. So let's see. If I know that this length is 15, that means that L1 and L2 have to add to 15, and they also need to be in a ratio of 1x to 2x. So I'm going to think about, well, if 1x plus 2x has to equal 15, then x must equal 5, which means that this distance must be 5, and this distance must be 10. And now we're in a ratio of 1:2. Now we can certainly double check it on the vertical axis, but we already know the x coordinate of our point, so we don't really need to do more work other than graphing it if we have the graph. But let's just double check, because sometimes we won't have the graph. Let's see if we can double check it on this side. So on this side, I'm just going to call these M instead of L to make sure I don't get confused. I'm going to put M1 on the top and M2 a larger piece, so somewhere in this area, I'm not really sure where. And I see that the distance from my A, this is from 10, and we're going down to -2. So from 10 to -2. So I know that M1 plus M2 has to equal 12. 12 is that distance from 10 to -2. So I'm going to call M1 1y and M2 2y. So I have 1y plus 2y has to equal 12, which means that y must equal 4. That means that M1 is 4, M2 is 8, and I am now able to see that this red point must be 4 units down from A, and we already said that it has to be 5 units right from A. So that gives us the point of -4, 6. And visually we should see that this point cuts AB in a 1:2 ratio. It should look like this is half of this length. So this would be the coordinates of point C. Okay, we've got one last example where the drawing is not made for you. Of course, I'm going to sketch a drawing. If you have me as a teacher, you know that I always like to see what's going on. So let's start by making a little sketch. We've got A, B, and C collinear, B between A and C, and we've got AB to AC is a ratio of 2:5. Let's be really careful here. This is tricky wording. A, B, and C are collinear. B is between A and C. So I'm just going to make a quick little sketch for myself that it's A, B, and C. Okay, the ratio of AB to AC, the whole, is 2:5. And we're given the coordinates of A and B, and we want to find C. This is what we are looking for. All right. So it's a pretty tricky problem. We're definitely going to need a little sketch to help us visualize what's going on. Okay, so I plotted A and B. I know that C is on the other side of B and it's collinear. So I'm going to make a line just so that I can make sure that I know that C is somewhere down here. Okay, so now I just need to figure out exactly where it is. Well, I'm going to continue thinking about vertical and horizontal. So my vertical is here. My horizontal is here. And I need to figure out how to cut each of these. But I know that B is 2 out of 5, so that if the whole thing is 5, and this is 2, that must mean that the BC portion is 3. So I'm thinking that this would be my 2x and this would be my 3x. So I know that 5x must equal that distance, or excuse me, I know that 2x must equal the distance between my two x values. So 2x must equal 4, since that is the distance between the x values. That gives me that x is 2, which means this distance here is 4. So to get from B down to C, we need to multiply that factor by 3. That means this must be a distance of 6. So if we continue along the x-axis from -2, 6 units, that's going to put us at 4 down here. So the x-coordinate of our new point must be 4. Now we're going to do the same thing for y. I need to get from 9 to 3 to whatever our y value is here. And again, since the total is 5, that means that the ratio of the smaller portion to the larger portion must be 3 to 2. So I'm going to put a 3y and a 2y. Again, I know that 2y must be the distance between 9 and 3, since that corresponds to the AB portion of the segment. That distance is 6, which allows me to write the equation 2y equals 6, and therefore that y equals 3. So if I know that y is 3, that means that this distance here must be 9. So to get from 3 down to the y value of my endpoint, I need to go 9 more units down from 3. So 3 down 9 units is going to get me to -6. So the final coordinates of my endpoint are 4 and -6. And again, when we look at this drawing, it should correspond with what looks right, because everything on the coordinate plane is drawn to scale, which is lovely. So this piece to this piece should be in a 2 to 3 ratio, and the little guy to the whole thing should be in a 2 to 5 ratio. Okay, so that was a lot. Let's just review the objectives we covered today. The first was we learned how to find the midpoint using the midpoint formula or using a diagram. The midpoint was halfway between the two endpoints of a segment, and if it's on the coordinate plane, you can use that formula where you plug in x1, x2, and y1, y2. Don't forget that midpoint means that these halves are in a ratio of 1 to 1. We also learned how to find a missing endpoint using either a visual model where you graph the midpoint, one endpoint, and extend to find the other one, or by plugging into the formula and saying what it has to equal. If we know x1 and we know y1, and we know what each of these expressions is supposed to equal, then we can calculate x2 and y2. The second thing that we learned today was how to cut segments proportionally. This is a pretty tricky topic. We had to take a segment on a coordinate plane and be told to cut it in a particular proportion, and we had to figure out where the point went so that this was, for example, in a ratio of 2 to 5. In addition, we had to take a segment where we knew that the ratio of a part to a whole was given, and we had to find that last missing endpoint. These are pretty challenging problems. So make sure that you spend some time working through them. Make sure that you're emailing your teachers and attending office hours if you need some help. And we will have a wrap up of these 2 lessons, distance formula, midpoints, and proportional segments, on Friday, where you can give us some feedback on how this worked for you this week. And you can let us know what you feel like you still need to work on next week.